Good morning and welcome to the GMAETS 41's live stream section class on exam focus review on physics 101. So we are going to look at certain likely exam questions with regards to UNIZIC Physics 101 examination as these students prepare for their exam. As always, we've got questions we are going to look at, and of course some of these questions are drawn from some topics in physics. This is actually in declaration of the GMAETS 41's TNA, Total Non-Stop Action Class. Yes, that's the preparation in terms of getting ready for the forthcoming examination. So if you have already joined the class, you can give a thumbs up to this lesson that is about to kick off. You can simply say that you are here so that I can kick off the class. Meanwhile, let me do well to share the link to this class to the GMAETS 41's 100 level group. And of course, as you receive the link, please, you can share it to your friends. All right, you're welcome. So. This is actually Physics 101, as I mentioned, and trying to get the link shared to our group so that those who are disposed can join this exam focus question review as I kick off. I'll have these questions that are extracted from scalars and vectors, from circular motion and simple harmonic motion related, and of course from rotational dynamics. Make sure, if you are not yet subscribed to the GMAETS 41's channel, do so. Don't waste any time. Click on the subscription button. You can also become a channel member. Is that okay? You can become a channel member so that you support this channel for us to continue to give you the best. All right. All right. So let's see what we've got. I'm going to dictate the questions. All right. I'll be dictating the questions. I won't copy them on the board to save time. Then just quickly give brief explanation to what you're meant to know about the question and answer it. I also want to quickly say this before we kick off, that the course outline of this course is the video lessons are fully available on the GMAETS 41's YouTube channel. You can just slide through to the GMAETS 41's playlist, and you would see your courses there: Physics 101, Chem 101, Maths 101, Chem 107, your practicals, Physics 107, your practicals. Say GMAETS 41 is a total package. GMAETS 41 is a total package here for you to give you the best, all right? And we're going to kick off right away. Okay, trying to send the link to some friends so that they can also All right, I'm sorry. Let me put on the sound. Please, can you hear the sound now? Can you hear the sound now? In here, you can indicate, please, if you can hear the sound now, please. Let me know if you can hear the sound. Work on the sound. I guess you can hear the sound now, right? I'm really sorry about that. That the sound was mute initially. So let's move on now, please. I am going to quickly repeat what we did in question 1 and 2, as well as 3, please. So because I don't know if the sound affected anyone initially. First question, which of the following operations is not valid for vectors? Which of the following operations is not valid for vectors? The option provided: A, addition of 2 vectors. You can add 2 vectors, so that one is valid. B, multiplication of a vector by a scalar. You can multiply a vector by a scalar. That one is valid. Then C, division of one vector by another vector. You cannot divide a vector by another vector, so that operation is not valid. Option D, taking the dot product of 2 vectors. Yes, you can take the dot product of 2 vectors, so D is valid. The correct option there is C, which we say you can't divide a vector by another vector. Then question number 2, we're given if vector 3, 4, and that is vector A, given as 3, 4, and vector B given as -4, 3. We are required to find the dot product. Given vector A, 3, 4, and vector B, -4, 3. What is the dot product? So it's simple. We have vector A, we have vector B. When you are seated in exam, I said you don't need to punish yourself bringing out this stuff. It's not necessary. All right, I just have to bring out this in case the direction vectors, also called the unit vectors, IJK, is used. In that case, it allows you to add up this guy. If you are given this trait, they say you should find dot product. Just go the x component times the x component. 3 times -4 will give you -12. 4 times 3 will give you +12. Add them up and you get 0. And then I explained something, that the fact that the dot product gave us 0 here actually means that these 2 vectors, they are orthogonal. They are perpendicular. They meet at right angle. The angle between them is equal to 0, is equal to 90 rather. The angle between them is equal to what? 90. That's the implication of the fact that the dot product gave you 0. So you want to take note, because an examiner can also ask you a question in that part, that if the angle between 2 vectors is equal to 0, the dot product, if the angle between 2 vectors is equal to 90 degrees, the dot product of the 2 vectors will be what? So the dot product will be 0. You don't need to solve anything there. Okay, now we are moving on. The third question, I've answered that. I'm also going to repeat it before the fourth. The cross product of 2 vectors results in, if you take the cross product of 2 vectors, the answer you are going to get will also be a vector. To be a vector. Cross product of 2 vectors produces what? A vector. If you do scalar product of 2 vectors, you will get a scalar. All right, let's move on to question number 4, as we have here. Question 4. A force F equal to 5i plus 2j minus 3k. F equal to 5i plus 2j minus 3k in Newton. A force given as this act on a particle moving with a velocity v equal to act on a particle moving with a velocity v equal to 3i plus 4j plus k in meter per second. V is equal to 3i plus 4j plus k in the unit of meter per second. What is the power delivered by the force? What is the power delivered by the force? Once again, a force F equals this vector here in Newton, act on a particle moving with a velocity vector v equal to this. The examiner requires that we find, okay, what is the power delivered by the force. Now, you're given this type of applied question in exam. What are you expected to do? Here you are asked to find the power you don't know. Power is unknown. You don't know the value of power. Please take note, dear students. When studying scalars and vectors, in multiplication of vectors, there are two ways you can multiply vectors. You can do either dot product, also called scalar product. You can do cross product, also known as vector product. Now, if I give you two vectors and I ask you to find something from the two vectors, are you following, right? If what I ask you to find, the quantity, is a scalar, it means that the two vectors, you are going to do their dot product, their scalar product, so that you can get that answer, which is a scalar. If the answer or the quantity I ask you to find is a vector, what you will do to the two vectors given to you to be able to get that answer they ask you to get, you are meant to do cross product. So that is the secret you want to take note of if an applied question is given to you like what we have here. These two vectors have been given to us. An examiner says we should find power. What I will ask myself is, power, is it a scalar quantity or a vector quantity? Clearly, in the study of scalars and vectors, power is a scalar quantity. Like I said, the GMAETS 41, by the help that we receive from our God and Helper Jehovah, I have created wonderful channel for you friends. You slide through the GMAETS 41's channel, you check through the playlist, you would see different courses available for you, both for 100 level, 200 level, and 300 level. All right. Now, for those in 100 level, you have the playlist there for these courses. In Physics 101, for example, you have video lessons classically arranged for you guys on scalars and vectors. Subscribe to this channel if you are here to subscribe. Take these lessons and you will learn very well, all right? You can also become a member of our physical tutorials if you so wish in Unizik if you are a Zikite. So since power is a scalar quantity, to obtain power from force vector and velocity vector, I am going to do dot product. I'm going to do what? Dot product. Because dot product or scalar product of two vectors will produce a scalar. Power is a scalar. Okay? So what I'm going to do now is take the dot product of these guys. Very simple. 5 times 3, you get 15, plus 2 times 4, you get 8, plus minus 3 times 1. The coefficient of this k here is 1. Minus 3 times 1 will give you minus 3. It is meant to be plus, then you take the multiplication and get minus 3. So adding up this, 15 plus 8 is going to give you 23. 23 minus 3 is going to give you what? 20. The unit of power in this case is watt. So the correct answer there is going to be 20 watts. That is the solution to question number 4. All right, you are welcome. You are welcome. Football Peaks. You are my oga. I'm not a chief. Okay. Thank you very much for the acknowledgements. I am glad to have you friends here. AG Gaming from India, you are highly welcome. You are highly welcome. We are happy to welcome you from Nigeria here. We are all one, you know, in a global world that we're living. Happy to have you here. Which class chapters? Okay, we are actually dealing with questions from scalars and vectors. Scalars and vectors. What we are doing here is actually an exam focused review for our friends here in Nigeria from UNIZIK, Nnamdi Azikiwe University. You can actually check the university from online. Okay, thank you, welcome to join us. All right, let us move on to the next question. We are looking at question number 5. Question number 5, and it reads, if A and B are two non-zero vectors, if A and B are two non-zero vectors, and their cross product is 0, and their cross product is 0, what can be concluded? What can be concluded? You know, in exam, your examiner will give you options. Are you following, right? But one important thing that can be concluded, taking into consideration the information provided here, that we have two vectors. These two vectors, they are not zero vectors. So they have values. Are you following? They are not 0. But then if you take the cross product of these two vectors, you will get 0. What can we conclude from there? We conclude simply that these two vectors, they are parallel. So the angle between them is equal to 0. That is the conclusion. Why is that so? Question number 5. This is what you should know. The mathematical definition of cross product of two vectors, assuming I give you vector A and vector B, and I say you should take the cross product of these two vectors, it is equal to the product, that is the multiplication of the magnitude of these two vectors and the sine of the angle between them. I'm going to write the formula on the board. Let us assume I have vector A and vector B, and I ask you to take the cross product given the magnitude. Are you following, right? It is expected to be equal to the magnitude of vector A times the magnitude of vector B. Then you multiply it by the sine of the angle between them. You multiply this product, this multiplication, by the sine of the angle between them. Now, this quantity is very, very important. This quantity, sine theta, this mathematical function here is very, very important. Now, I am telling you that the cross product of the two vectors is equal to 0. What will make the cross product of two vectors to be equal to 0? Mathematically, that is when this mathematical function, sine theta, gives you 0. The question will now be, what will be the value of theta for sine theta to be 0? What will be the value of theta for sine theta to be 0? I'm going to write that here. If theta is equal to 0 degrees, we know that sine 0 is equal to 0. It simply means that the magnitude of A times magnitude of B multiplied by sine 0 will produce what? 0. Therefore, the cross product of the two vectors in that case will now be equal to what? 0. So that is it. Once the cross product of two non-zero vectors is equal to 0, it simply means the angle between the two vectors is equal to what? 0. And when the angle between two vectors is equal to 0, you can conclude that the vectors are what? Parallel. The vectors are what? Parallel. So vector A and B are parallel. That is to say, they are moving in the same direction. So you want to take note of that. I've been able to give a clear interpretation to what the answer to this question is meant to be. We are moving on to the next question. Remember, if you have any question, please feel free to ask. And if you are here to subscribe to our channel, do kindly hit the subscription button. You can also support the growth of GMAETS 41, as I'm committed to giving students the best. Are you following, right? To support this channel, kindly become a channel member. Click the join tab below this video lesson or on this channel, and then support us with whatever that is convenient for you. We have the gold level, we have the platinum level, we have the diamond level. Share these links to your friends and invite them to join the channel as well too. Especially for our friends in Unizik, your exam is just counting, the time is ticking, close at the door. But like I always advise, you don't need to be scared. Once you do the needful, you don't have problems. Your exam questions are stuffs that can easily be answered. Yes, that's the truth. Your examiners are not interested in your failing. Your exam questions are those that can easily be answered. The answers are right there with you. And on this channel, the video lessons so covers areas in which your exam questions asks a magnitude of 1 and any direction. B, a magnitude less than 1. C, a magnitude greater than 1. D, a fixed direction along the x-axis. The correct option is A. A unit vector, the word unit means 1. So the magnitude of a unit vector is 1, and it can be in any direction. Specifically in the study of vectors, we give up to 3 dimensions to vector. We have vector in 1 dimension, vector in 2 dimensions, vectors in 3 dimensions. When a vector is in 1 dimension, it's simply represented by a line. So a line is simply a vector in 1 dimension. When a vector is in 2 dimensions, we say that that vector is in plane. That is where you have the x and y axis. Can also be x and z axis or y and z axis. We have vector in 3 dimensions. A vector in 3 dimensions is said to be in space. It's said to be in space. There you have the 3 coordinate system, x, y, z. So a unit vector whose magnitude is 1 can take any direction. That is why the correct option is option A for question number 6. Option A. All right? Option A. A unit vector has a magnitude of 1 in any direction. All right, that's going to take us to the last question under scalar and vector, as we are going to consider in this live stream. Given vectors A equal to, that's question number 8. Given vectors A equal to 3i minus 2j plus k, and B equal to I plus 4j minus 2k. Calculate the dot product A dot B and determine the angle between them. I'll take the question again. Given vectors A equal to 3i minus 2j plus k and B equal to I plus 4j minus 2k. Calculate the dot product A dot B and determine the angle between them. I think my interest really is the angle between these 2 vectors. The dot product is 1 plus 1. We already have 2 questions solved with dot product. Now one may wonder, what about questions in cross product? I had previously released a question, right? Yeah, released a past question review where I covered question that has to do with cross product. You can check through in our past question and answer playlist on this channel, so you can get at least questions covered by cross product. All right. I'm going to wipe this part of the board as we solve this question, number 7. Is it question number 7 or question? Don't know, did I mix up the numbering? Question 5. Question 6. All right. Question 7. I jumped question 7. What I dictated was actually question 8. But it doesn't matter. I'll take that question 7 to 8 now. Let me leave this for a moment. So let's say question number 7. Given vectors A to be equal to, or let me write it as question 8 because I'm following the numbering of the questions as presented in our WhatsApp group for 100 level students of Unizik student. All right, A is equal to 3i minus 2j, then plus k. And then B is equal to I plus 4j minus 2k. Now we are asked to find the dot product A and what? B. We are asked to find what? The dot product A and B, and then find the angle between them. So I'm going to be fast in obtaining the dot product. Then we'll move on to the angle between them. Dot product, I'm going to do 3 times 1. The coefficient of I here is 1. 3 times 1 is going to give me 3. Then plus minus 2 times plus 4. The j component or y component, okay? Minus 2 times 4 will give you minus 8. So you see, I shouldn't have put plus here, but it doesn't matter. I need you to understand something about scalar product or dot product. You add those guys up, okay? Once you do the dot product, you add them up. Then here we have 1. This is going to be plus. We have 1 as the coefficient of k times minus 2, which will give us minus 2. If we simplify this, this is 3 minus 8 minus 2. 3 minus 8 is minus 5. Then minus 5 minus 7 will give us minus 2 will give us minus 7. So the dot product of this guy is minus 7. The dot product is minus what? 7. Now we have to find the angle theta. The angle between two vectors can be obtained using this formula, cos inverse the dot product of the vectors divided by their magnitude. So what we're going to do is to quickly obtain the magnitude of the two vectors. Are you following, right? We know the dot product already, which is minus 7. So let us obtain the magnitude of A. To get the magnitude of A, you use Pythagoras theorem. Come to this guy, pick the coefficient of the ijk, and then square them. We're going to have something like this. Now you notice I was not interested in this minus 2. You don't need to when you are solving magnitude. If you are trying to obtain the magnitude of two vectors, the negative sign in that value is not of any use. Reason, the square will still kick out that negative sign. So this is going to give us 9 plus 4, which is 13, plus 1, which is square root of 14. 3 square is 9, 2 square is 4, you get 13. 1 square is 1, add it up, you get 14. So square root of 14. The magnitude of B, do the same thing. The coefficient of I here is 1. It's going to be 1 squared. Plus that 1 there for J is 4. 4 squared, then minus 2 here. You square it. I'm not going to write that minus. It's of no use. It's a waste of time to me. All right, so 4 square is 16. Plus 1 square is 1. You get 17. 2 square is 4. 17 plus 4 is 21. So this is square root of 21. We can now substitute for this angle, for the values we have in this formula here to get this angle. Cos inverse A dot B is minus 7 divided by magnitude of A times magnitude of B, which is square root of 14 times square root of 21. From the knowledge of sod, if you are multiplying this guy, it is 14 times 21. You use 1 square root to cover them up. So you have to reach out for your calculator and work out this. We can do it once. If I multiply 14 by 21, this is giving us 294. So that this can still be written as cos inverse minus 7 all over square root of 294. Let us now obtain the cos inverse. Okay, so your shift key, and then you press your cos. It will invoke cos inverse. Then minus 7. We are dividing it by square root of 294. Right, so cos inverse negative 7 divided by 2 square root of 294. Okay, perhaps let me evaluate square root of 294 first. So you see what you're going to get at 17.1464 cos inverse -7 all over 17.1464. So I can now go for the cos inverse. And the -7 divided by 17.1464. So this gives us theta, the angle, to be equal to 114.1 degree approximately. 114.1 degree. And this, of course, is the angle between the two vectors. That's good. So we are done with this. You've seen how we obtain the angle between two vectors using the knowledge of dot product. So let us take the last question, question number 7. Let's take the last question, number 7. No, this is question 8. I omitted question number 7 earlier. So let us see what we've got there. In question number 7, we have the question read: the vector r equal to x, y, z is perpendicular to both vectors A equal to 1, 2, 3 and B equal to 4, 5, 6. What is the possible representation of R? I love this question. Yeah, I love this question. Very interesting question. The vector R equal to x, y, z, x, y, z is perpendicular to both A equal to 1, 2, 3 and B equal to 4, 5, 6. What is the possible representation of R? See, this is a simple question, but tricky. If you have two vectors, and I tell you that you have another third vector that is perpendicular to these two vectors, to get that third vector, what you do is the cross product of these two vectors. Is that okay? Because again, we define cross product of two vectors as another vector which is perpendicular to the plane containing the first two vectors. That is, when anytime you are given two vectors and you are told to find another vector that is perpendicular to the first two, right? All you have to do is cross product. I don't think this space will be enough for me to do that cross product work. So I guess you're going to wipe this question number 8, and then I'll solve that question number 7 there. So take a look at this. I'm going to wipe it. We'll solve question number 7. Because good enough, this question number 7 is on cross product, and that is interesting. At least we would have to solve a cross product question. All right, so I want to wipe this. So question number 8, the solution, I mean number 7 rather. It seems like I really like number 8. Don't know. Question number 7. The vector R equals x, y, z is perpendicular, that's what is being said, to both vector A. And vector A is given as 1, 2, 3. And B is given as 4, 5, 6. What is the possible representation of vector R? Vector R, we don't know. What is the possible representation? And I explained after dictating the question that when you are given two vectors and you are told to find another vector that is perpendicular to both of them, all you have to do is cross product of the two vectors. So here, to obtain our R is equal to the cross product of these two vectors. And how do you solve the cross product of two vectors? Remember, these guys are three-dimensional vectors. They are vectors in space. That's why they have three coordinates. If you are to fix your ijk, this is going to be 1 times I, which is I plus 2j plus 3k. And this one is going to be 4i plus 5j plus 6k, right? So in solving the cross product, what you have to do is to extract your ijk first. You're going to form a 3 by 3 square matrix. Once you extract your ijk, now, we were not told the order in which to do the cross product. We weren't told. So we are going to define it ourselves following the order in which the question is presented. They gave us A and B. So if we are looking for R, we are going to do vector A cross vector B. I'm saying this because the result you obtain from vector A cross vector B is not exactly the same as the result of vector B cross vector A. Because cross product is not commutative. If you do A cross B, you won't get exactly the same thing as B cross A. You get the same number as value, but one will be negative of the other one. So in this case, what I'm trying to say is that to get our vector R is going to be A cross B. Let me write it first, A cross B. And so to solve your A cross B, first you pull out the unit vectors ijk, use it to form row 1. Then in the second row, you enter the values, the scalar values of vector A, which are given as 1, 2, 3. And then next, you enter in the third row the scalar component, the scalar values of vector B, which are given as 4, 5, and 6. Then you are going to solve the determinant of this 3 by 3 matrix. So we are now moving on to matrix, okay? And how do you solve the determinant? It's very simple. It's not something you stress yourself, right? Come over here, put plus, minus, plus is a standard. Then I'm going to extract plus I. If I pick this I will delete this column. I will delete this row. Don't go canceling anything. Use your mind's eye, your imagination to assume that this column where I is no longer there. This row where I is no longer there. So you see, you'll be left with 2, 3, 5, and 6. Then watch the way you handle what is left, the elements that are left. You're going to multiply this way first. 2 times 6. And 2 times 6 will give you 12. Then fix minus. And then multiply this way. 5 times 3, which will give you 15. Good. Pick this guy, delete the column, delete the row. You are left with this element. Multiply this way, minus, multiply this way. Next, I will pick the second guy here, which is minus j. Delete the column, delete the row. You are repeating the same thing you did with that I. Delete the column, delete the row. You'll be left with 1, 3, 4, 6. 1 times 6 is 6, minus 4 times 3 is going to give you 12. Then finally pick plus k and repeat the same thing. Delete the column, delete the row. You'll be left with 1 times 5, which will give you 5, minus 4 times 2, which will give you 8. So that the representation of the vector we are looking for, vector R, will now be 12 minus 15 will give you minus 3. Minus 3 times I is minus 3i. 6 minus 12 will give you minus 6. Minus 6 times minus j will give you plus 6j. Then 5 minus 8 will give you minus 3. Minus 3 times plus k will give you minus 3k. This is the representation of R. This is actually the third vector that is perpendicular to the plane containing A and B. And that is how we solve that question. So we are done with this part of vectors. And I hope you enjoyed this solution. We are going to see some other question moving away from vectors. At least from the question I have here, we're going to look at question extracted from circular motion and simple harmonic motion related. And then, of course, we're also going to look at these other questions that we have from our group. The other one is on rotational dynamics. So you take a look at this, and you can put the solution down as I wipe what we have on the board. All right. Okay, so let us try to round off with the remainder of the question here. The next area of focus, the questions we have here from the GMAETS 41's WhatsApp group for 100 level student. So the first question we're going to look at here, that question is actually on center of mass. I would like to release a pre-recorded video on that specifically because there are certain things I would want to explain to you guys. Doing that would take a whole lot of our time in this particular live stream. So the question I'm going to deal with it, and possibly said soon I will release the solution to that. I think I'll read it out, but I won't solve that. Like I said, I have my reason. I've told you due to the fact that there are certain things I need to still give an explanation to, which I wouldn't do that right away because of time. A uniform thin rod of mass, 4.49 kilogram pivots about an axis through its center and perpendicular to its length. Two small bodies, each of mass 0.523 kilogram, are attached to the ends of the rod. What must the length L of the rod be so that the moment of inertia of the three-body system with respect to the described axis is I equal to 0.889 kilogram square meter? So that's the question. Like I said, I'm going to handle that question specially. Okay? Let us move on to question number 2 there, which of course I'm going to take as question 1 for us here. Yep. But let me still maintain question 2 here. No problem. Let me maintain it as question 2, so that those that are in the group will be aware of the fact that there's a question that is yet to be dealt with. Question number 2. A disk is rotating for 8 seconds. A disk is rotating for 8 seconds. It has a constant angular acceleration. It has a constant angular acceleration of 15 radian per square second. If the initial velocity is 3.5 radian per second, find the final angular velocity. So this is what we have. The disk is rotated for 8 seconds. Yeah. Rotated for 8 seconds, or it's rotating for 8 seconds as the question presented it. It has a constant angular acceleration. Angular acceleration, we use alpha for it in rotational dynamics. This question is on rotational dynamics. And then this is 15 rad per square second. The one I have here is radian per second. That unit is wrong. It's meant to be radian per square second as angular acceleration. If the initial velocity, which I'm going to use initial angular velocity, I'm going to use omega for it as usual. The initial velocity is 3.5 rad per second. Please take note. In the question it was mentioned, if the initial velocity, that velocity there is not V. Reason, the unit given, 3.5, is rad per second. That's radian per second. And you know that radian per second is the unit of angular velocity. So this is not our tangential velocity. You take note. We have to find the final angular velocity. Omega 2, we don't know. Now, if you look at this question given, the data we have here fits the first equation of motion. When studying rotational dynamics, The formulas we have in rotational dynamics, they are analogous to the equations we have when studying translational motion. In our physical class, I have dealt with this. On the GMAETS 41 Physics 101 playlist in this channel, you also have video lessons on rotational dynamics that shows you the rotational analogy in terms of equation when you are dealing with rotational variables and translational variables. So here we are going to use the first equation of motion, where we have that the final angular velocity is equal to the initial angular velocity plus alpha t. We know this equation from translational motion as v equal to u plus at. So we are looking for the final angular velocity. We're going to substitute 3.5 for the initial, and then plus the angular acceleration, which is 15, multiplied by 8. Working this out, if we multiply this by 15 times 8, that's going to give you something like 120, I guess, right? 8 times 5 is 40, right? 0 carry 4. 8 times 1 is 8 plus the 4, you get 12. All right? So that's going to be 12. That 12, we are adding it to 3.5. This is going to be 120 rather. That 120, you add it to 3.5, you should get 123.5 in the unit of rad per second, radian per second. You can work that out with your calculator if you so wish. 15 times 8, and then 120, you are adding 3.5 to it. So you get 123.5 in the unit of radian per second. So that's the solution to that question. All right, let's move on. The next question I have here, question number 3, it reads, a constant torque of 1.56 Newton meter is applied to a rotating solid disk of radius 15 centimeter and mass 5.71 kilogram. What is the angular velocity of the disk after 10 seconds? What is the angular velocity of the disk after 10 seconds? Once again, the rotational dynamics problem. Now, in this question, we are given the value of the torque. The torque, which I use this symbol for, is given as 1.56 Newton meter. And then it is rotating. We are given a solid disk. That solid disk, we have the radius given. Radius of the solid disk to be 15 cm. We have to convert this, divide it by 100, you get 0.15 meter. And then we are given the mass of that solid disk. The mass is 5.71 kilogram. The time during which this guy acts is 10 seconds. We are asked to find the angular velocity. We do not know. The angular velocity we do not know. Now, how do we obtain our angular velocity? If you look at this question, we know the radius of the disk. We have to find the angular velocity. Angular velocity has this various formula. I can actually obtain it using this formula, where I can now say the angular velocity is v over r. If this is the formula I'm going to use to calculate this, then I have to find a way to get my v, tangential velocity. However, looking at the data presented, it is really not possible as it stands to obtain the value of v. Do you get that right? But then think about this also. I know that angular velocity is also related to angular acceleration. So I'm trying to guide you to understand why you can't think of a certain formula and why the other formula likely would work. We have this formula that angular acceleration is velocity divided by time, which means that velocity, that is angular velocity, will be angular acceleration times time if you cross multiply. Now, if you look at this data provided, I have my time, and I can tell you that it's possible for me to get this angular acceleration. I can get this angular acceleration. Why? Because it gave me torque. There is this relationship between angular acceleration and torque. So I can actually obtain my alpha using this torque. As a matter of fact, torque is equal to moment of inertia times angular acceleration. Now, if I am saying that, okay, that torque is equal to moment of inertia times angular acceleration, it means that angular acceleration is torque divided by moment of what? Inertia. The question will now be, okay, I know the torque, but I was not given moment of inertia. Since I was not given moment of inertia, I have to go and find moment of inertia. So the idea in this question is, if I get moment of inertia, I'll fix it here, divide torque by that moment of inertia, I will get my what? Alpha, which is angular velocity. And angular acceleration rather. And once I get my angular acceleration, my problem is solved. I'll multiply by time to get my angular velocity, which I am being asked to find. The question now is, how do I get my moment of inertia? Let us look at the question, please. That is why the examiner mentioned the shape of the object. We are told that this guy is a solid disk. We are told it is what? A solid disk. Is that okay? That's what the question said. It's a solid disk. And because it is a solid disk, we can actually obtain the moment of inertia of that solid disk. We are not told the axis about which the solid disk is rotating. We are not told the axis. And whenever the axis of rotation is not mentioned, by standard, we take it that that object is rotating about its center. It's just like having something like this, and then I say it is rotating like this. Are you following? I pivoted it this way at this point, and I now say it is rotating on my finger like this through its center. Are you following, right? So for solid disk, we have the moment of inertia. This is what I'm going to do. To get my angular velocity, it is going to be, I've analyzed it here, alpha times t. That's what I'm going to use in solving. But alpha is equal to torque divided by moment of inertia of that solid disk. Are you following? Now, I have to obtain the moment of inertia of that solid disk. That's the first thing I have to do. Look at the problems we have in this question. I don't know alpha. This is my problem. I don't know it. Coming here, I found out that to get alpha, I can use this torque divided by moment of inertia. That is good. So once I get alpha from here, I can substitute here. But then the problem is, I don't know the moment of inertia of that solid disk. I have to go and find it out. So once I know the moment of inertia of that solid disk, my problem is solved. So I'm going to give you the moment of inertia of the solid disk. So I can say also, I, for a disk, for a solid disk, the moment of inertia is equal to mr squared divided by 2. That is the moment of inertia of a solid disk when the disk is rotating about its axis. Are you following, right? That's the moment of inertia. So with this moment of inertia, we can now obtain our I with this formula. We know the mass. The mass is 5.71. And then we are dividing it, okay, multiplying it by the radius. The radius is 0.15. I'm going to square it. And then we shall divide by 2. So with this, my moment of inertia I for the solid disk is equal to, let's evaluate it with a calculator and see, 0.15, I square it first, and then multiply by 5.71. Then I am dividing this by 2. So this gave us 0.064. 0.064, let's say 2. The unit of moment of inertia is kilogram square meter. You see, my problem is as good as solved. Now that I've obtained my moment of inertia, it implies that my angular acceleration will be equal to torque divided by moment of inertia, where torque is 1.56 divided by the moment of inertia I obtained to be 0.0643. Therefore, my angular acceleration is equal to, reach out for your calculator, and then you have 1.56. You have 1.56. We are dividing it by 0.0643. 0.0643. And this is what it gave to me, 24.26. 24.26. The unit is rad per square second. In conclusion, it means that my angular velocity, which I was asked to obtain, because that's what I was asked to obtain in the question, the angular what? Velocity. Let's see. Yeah, the angular velocity after 10 seconds will now be, I'll come back to this equation, alpha times t. And what is our alpha? 24, the angular velocity, 0.26, times the time. And the time is 10 seconds. If you multiply this, you're going to get 242.6 radian per second. This is the angular velocity after 10 seconds for this disk. Please take note that the moment of inertia for a disk, as I used here, is also the same as the moment of inertia of a given cylinder. You want to take note of that. Okay? In our group, I had already dropped the moment of inertia of this guy. Solid